Let's look at the linearization and differentials formulas and see how they're used to approximate a function near a point. Linear approximation is a method used to estimate the value of a complicated function f of x at a point x, that's this point right down here, near a point x is equal to a with a known function f of a, that's this point right here. The tangent line to the curve at x is equal to a that I've drawn down here in green is used to approximate f of x. This is the value that is used for that approximation. F of a is the y value that we know. F of x is the y value that we are approximating. And then L of x is the approximation. The linearization of f of x at x is equal to a is the y value of the line that is tangent to the curve y is equal to f of x when x is equal to a. That's just this green line that was drawn up here. This is the y value that we're talking about. The equation of our tangent line can be written as y minus y1 is equal to the slope m times x minus x1. x1, y1 is then just the point a, f of a, and our slope m is the derivative of the function at the point x is equal to a. If we plug both of those in, we get that y minus f of a is f prime of a times x minus a, and then we want to solve for y, and it's just f of a plus the derivative of our function at a times x minus a. This y value is our linearization L of x, so the linearization is just f of a plus f prime of a times x minus a. We say that f of x is approximately L of x when x is near a. When we're working with application problems, oftentimes linearization is best described using differentials. When we use differentials, we need to use a different notation than we did with linearization. With differentials, this point here is going to be notated by x f of x instead of a f of a, and that's the function value that we know. This point is the function value that we are approximating, and the approximate value is given up here by this point. When we use differentials, we focus on the change between this point here in yellow and this point here in pink. dx or delta x is the actual change in x. Delta y is equal to f at x plus delta x minus f of x, and that's the actual change in y. And then we use differentials to approximate that actual change in y with dy, which is equal to f prime of x dx. That's this distance right up here, and that is the approximate change in y. The formulas with linearization and differentials look very different, but they are doing the exact same thing. And that is approximating a function value that is near a function value that is known.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.